Hi guys, let's look at the homework questions of exercise 5e. We are on the chapter Quadratic Equation. Before we look at the questions, let's revise the concept that we've done. So first thing we did was the standard form of a quadratic equation, which is ax squared plus bx plus c is equal to 0. Next, we talked about the roots of the equation, which is if b, which is equal to b squared minus 4ac is equal to 0, then the roots are real and equal. Next, if b square minus 4ac is more than 0, then roots are real and unequal. Next, b square minus 4ac is less than 0, then the roots are imaginary. The next exercise was basically about solving quadratic equation by splitting middle term, which is the factorizing uh, method. So splitting middle term. And then in the next one, we talked about solving quadratic equation using the formula, which is x is equal to negative b plus minus square root of b square minus 4ac whole upon 2a. So this is basically what this chapter has been about. Let's go ahead and look at the homework questions of exercise 5e. So the first homework question was question number 5. It says x plus 4 upon x is equal to negative 4 and x is not equal to 0. Let's take the LCM. The LCM is x, so this is x squared plus 4 is equal to negative 4, which means x squared plus 4 is equal to negative 4x cross multiplying, which gives me x squared plus 4x plus 4 is equal to 0. This is x plus 2 whole square. Yes, this is x plus 2 the whole square, which is equal to 0, which means x is equal to negative 2 or x is equal to negative 2. In both the cases, the value of x is negative 2. So that's our answer. X is equal to negative 2. Let's look at the next one. The next one is question number 6. Now this is the kind of a question which is not a quadratic equation yet, but we need to convert it into a quadratic. So number 1, let x squared is equal to y. That gives us 2 times x squared the whole square minus 5x squared plus 3 is equal to 0. This means 2y squared minus 5y plus 3 is equal to 0. So I need to find factors of 3 into 2, that's 6, the sum of which would be negative 5. So negative 3 and negative 2, yes, that's fine. So 2y squared minus 2y minus 3y plus 3 is equal to 0. Grouping it the way I've underlined, we have 2y times y minus 1 minus 3 times y minus 1 is equal to 0. Y minus 1 is common in these two elements. So we have y minus 1 times 2y minus 3 is equal to 0, which means y minus 1 is equal to 0 or 2y minus 3 is equal to 0. The first one gives us y is equal to 1 or y is equal to 3 by 2. That's correct. Now y is a variable which we've introduced. So let's replace it back with x, which means x squared is equal to 1 or x squared is equal to 3 by 2. This gives us x is equal to plus minus 1. The square root of 1 is plus minus 1. In this case, the square root of 3 by 2 is plus minus root 3 upon 2. So these are the four answers. The power was 4, so we were expecting 4 answers in any case. Good, let's look at the next one. The next homework question was question number 9. It says 2 times x squared plus 1 upon x squared minus x plus 1 upon x is equal to 11. So again, this is not in the form of a quadratic yet. So let x plus 1 upon x is equal to y. If we square both sides, what we have is x plus 1 upon x the whole square is equal to y squared. This gives me x squared plus 1 upon x squared plus 2 is equal to y squared, which means x squared plus 1 upon x squared is equal to y squared minus 2. Perfect. So now that we've got the value of x squared plus y 1 upon x squared, we've taken this as y. Let's substitute. So when I substitute, I get 2 times y squared minus 2 minus y is equal to 11. Yes, that's 2 times y squared minus 2 minus y is equal to 11. Let's open the bracket. So that's 2y square minus 4 minus y minus 11 is equal to 0. This gives us 2y square minus y minus 15 is equal to 0. So we've got to find factors of negative 15 into 2. That's negative 30, the sum of which should be negative 1. So that's negative 6 into 5. Yes, that's correct. So 2y square minus 6y plus 5y minus 15 is equal to 0. Grouping it the way I have underlined, 2y times y minus 3 plus 5 times y minus 3 is equal to 0. That gives us y minus 3 times 2y plus 5 is equal to 0, which means y is equal to 3 or y is equal to negative 5 upon 2. So we've got two values of y. Let's put it back in the assumption that we've taken. So the first one is x plus 1 upon x is equal to 3, or x plus 1 upon x is equal to negative 5 upon 2. Let's take the LCM. We get x squared plus 1 upon x is equal to 3, or x squared plus 1 upon x is equal to negative 5 upon 2. Let's cross multiply. X squared plus 1 is equal to 3x, or 2 times x squared plus 1 is equal to negative 5x. Let's bring it on one side. So x squared minus 3x plus 1 is equal to 0, or 2x squared plus 5x plus 1 into 2, that's plus 2, is equal to 0. So we have two equations. Let's call this equation 1. Let's call this equation 2, and let's solve them separately. So let's work with first equation now. So first equation is x squared minus 3x plus 1 is equal to 0. I can't find factors of 1, the sum of which will be negative 3. So let's use the formula. A is equal to 1, B is equal to negative 3, C is equal to 1. So x will be equal to negative b, in this case negative of negative 3, that 3 plus minus b square, which is 9, multiplied with 4 into a into c, the square root of this upon 2 into 1, which means x is equal to 3 plus minus root 5 upon 2. Now since the question hasn't given us how many decimal places they want the answer in, this will be an acceptable answer. Let's look at solving the second question, the second equation. The second equation is 2x squared plus 5x plus 2 is equal to 0. I need to find factors of 2 into 2. That's 4, the sum of which should be 5. So that will be 4 and 1. Yeah, 4 into 1 will be 4, and 4 plus 1 will be 5. So 2x squared plus 4x plus x plus 2 is equal to 0. Grouping it the way I've underlined, 2x times x plus 2 plus 1 times x plus 2 is equal to 0. X plus 2 times 2x plus 1 is equal to 0, which means x is equal to negative 2, or x is equal to negative half. So we have four values of x: negative 2, negative half, 3 plus root 5 upon 2, or 3 minus root 5 upon 2. Interesting question, and in fact very long. So you could put a small star on this question. Good, let's look at the next one. The next one that we're doing is question number 14, part 2. It says find the value of x when x belongs to integer. So I need to find factors of negative 12, the sum of which would be negative 4. So that will be negative 12 can be written as negative 6 into 2, which means negative 4 can be written as negative 6 plus 2. Perfect. So let's split negative 4 as x squared minus 6x plus 2x minus 12 is equal to 0. Grouping it the way I've underlined, x times x minus 6 plus 2 times x minus 6 is equal to 0, which means x minus 6 times x plus 2 is equal to 0, x minus 6 is equal to 0, or x plus 2 is equal to 0, x is equal to 6, or x is equal to negative 2. So these are the two possible values of x. That's our answer. This was a fairly simple question. And since just before that, since they've talked about integer, both values satisfy that criteria of being integers as well. So let's look at the next one. The next one is question number, just give me a second, let me just open that file. Yeah, the next question is question number 17, part 1. So it says x times x plus 1 plus x plus 2 times x plus 3 is equal to 42. Let's open the bracket. So this is x square plus x square plus 2x plus 3x plus 6 minus 42 is equal to 0. Right, that's correct. So let's combine like terms together. X square plus x square, that's 2x square, x and 2x plus 3x, so that's plus 6x, and 6 minus 42, that's negative 36 is equal to 0. I notice that all three elements have 2 in common, so let's divide both sides by 2. We get x squared plus 3x minus 18 is equal to 0. Now I need to find factors of negative 18, the sum of which is plus 3. So negative 18 can be written as 6 into negative 3. Yes, and 6 plus negative 3 is equal to 3. Perfect. So our factors are 6 and negative 3. So this gives us x squared minus 3x plus 6x minus 18 is equal to 0. Grouping it the way I've underlined, x times x minus 3 plus 6 times x minus 3 is equal to 0. X minus 3 times x plus 6 is equal to 0. X minus 3 is equal to 0, or x plus 6 is equal to 0, which means x is equal to 3 or x is equal to negative 6. So these are the two possible solutions for the given question. Good, let's look at the next one. The next one that we are doing is question number 18, part 2. It says for find the value of m so that the equation has real and equal roots. Also find the solution. So first let's figure out the value of m, and then we'll solve it to find the value of x. So since roots are real and equal, which means b, which is equal to b square minus 4ac, is equal to 0. In this question, a is 3, b is 12, and c is equal to m plus 7. Let's substitute values. So b square minus 4ac is equal to 12 square minus 4 into 3 into m plus 7. And this is equal to 0. This gives us 144 minus 12 into m, that's negative 12m, minus 4 into 7, that's negative 84, is equal to 0. This gives us 144 minus 84, that's 44, and 16, that's 60, is equal to 12m, which means m is equal to 5. So we figured out the value of m for which this given equation will have real and equal roots. Now put m is equal to 5 in 3x square plus 12x plus m plus 7 is equal to 0, and what we get is 3x square plus 12x plus 5 plus 7, that's 12, is equal to 0. I notice all elements have 3 in common, so let's divide everything by 3, and what we get is x square plus 4x plus 4 is equal to 0. We just got this in one of the previous questions. This is nothing but x plus 2 the whole square, which is equal to 0. Yes, that's x square plus 4x plus 4, which means x plus 2 is equal to 0, or x plus 2 is equal to 0, which is basically the same thing, which means x is equal to negative 2 or x is equal to negative 2. So both the solutions are equal, which means x is equal to negative 2, which is what we were expecting in any case because it said it has real and equal roots. Good, that brings me to the last homework question from this exercise, which is question number 19. It says without solving the equation, find the value of p for which the given equation has roots are equal. Okay, so since roots are equal, which means therefore b square minus 4ac is again equal to 0. This was a question in your board exam which came in 2012. No, not 2012, 2010, sorry. Okay, so in this question, A is equal to P, B is equal to -4, and C is equal to 3. So let's put the value. B square minus 4AC is equal to -4 square minus 4 into A, which is P, into C, which is 3. This is given equal to 0, which means 16 minus 12P is equal to 0, which means 12P is equal to 16, which means P is equal to 16 upon 12. That's 4 into 3, 4 into 4. Therefore, P is equal to 4 by 3. If you want, you should write it always in the mixed fraction. So that's 1, 1 upon 3. So that's the value of P for which the given question or given quadratic equation will have real and equal roots. Perfect. That brings me to an end of this exercise as well as this video. I hope you liked the video. If you have any questions or queries, feel free to write into me. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.